Right, let's go ahead and get started. All right, hello everyone. Thank you for attending to our show. Hello everyone. Let's start over. Thank you for attending our Shout Out Saturday event today with Juliana Novic, data scientist at Pandata, on ethics in AI and machine learning, where we will discuss overcoming obstacles with ethics and tech industry advice in AI and machine learning. My name is Dianne Jardinez, and I will be your moderator for this Shout Out Saturday series event. I do want to let everyone know that this event will be recorded. And so now we can go ahead and go to our agenda. Our agenda for today are introductions, the main session of questions we have for Julie, and opportunity for you, the audience, to ask your questions, which again, you can put in the Q&A for Zoom. Women Who Code's mission is to inspire women to excel in technology careers, and our programs are designed to support women in being and becoming leaders in the industry by providing tools and opportunities and inspiration to fuel professional success. And we are growing. We've reached to more than 120 countries with a network of more than 230,000 technical women. I do want to take a moment to discuss about our code of conduct. For Women Who Code, we are dedicated to providing an empowering experience for everyone who participates in or supports our community. Our events are intended to inspire women in technology careers, and anyone who is there for this purpose is welcome. We do not tolerate harassment of members or event participants in any form. If you would like to read the full version of our code of conduct, please feel free to visit the link displayed. All right, so let's go ahead and get started. Julie, are you ready to start?
I am ready.
Great, I'll go ahead and introduce you. So we have here today Julie Novic. She received her PhD in anthropology from the School of Human Evolution and Social Change at Arizona State University. There, she explored research questions on consumer economics, identity, and urban space from the lens of quantitative archaeology. After a postdoc at Colorado College, Julie realized that she wanted to have an impact on modern day society. This led her to the Case Western Reserve Data Analytics Bootcamp, where she learned the Python, SQL, and machine learning skills needed to take her from researcher to data scientist. Within the data science world, Julie is interested in the ethical application of artificial intelligence and solutions to important business challenges. Her focus on ethical AI led her to Pandata, where approachable, ethical, human-centered AI is not just a slogan, but a core part of company culture. All right, Julie, thank you again for joining us and being a part of our Shout Out Saturday series. We do appreciate your time.
Thank you for having me. I'm glad to be here. I'm excited.
We're excited to have you. So our theme is all about how to ethics on AI and machine learning, and I'll go ahead and dive into our questions. So, what is data ethics?
That's a very good question, and it's a complex question as well. So a lot of people, when they think about data ethics, their first thought comes to fairness, whether or not an algorithm is treating individuals, disadvantaged segments of the society differently, or groups of different people in a different way. So for one of the most powerful examples is the Compass recidivism AI model that was disproportionately false with African Americans when it gave its results of a chance of recidivism. It was saying more individuals who are African American would be recidivists, when in fact that it was a false positive. Like, that is a very powerful example of fairness that has in AI and an algorithm that could be construed as not being fair. And there's all sorts of debate on what fairness means. and what definitions we have of fairness. So it's a very complex issue, even in that regard. But that's not the only part of ethics to date in data ethics. There's more than that. It really, for the definition that I view, is that putting humans in the center of machine learning. And by doing that, we're focusing on their needs, human needs for privacy, human needs to trust that the algorithm is making the right decisions, human needs to understand what the algorithm is trying to tell them, in addition to that fairness. And there are probably more issues to fairness, to data ethics that I'm missing, but those are the ones that come to mind when I think of data ethics right off the cuff. And what it means to have data ethics is to also be transparent in what your model is trying to accomplish and what it's trying to do. And all that, again, that all ties back to being human-centered in your approach to machine learning, putting people at the center and not the algorithm at the center of what you're trying to do. And that's my definition of data ethics.
So you talked a little bit about it, like the algorithm. Do you have a definition of what it means for an algorithm to be ethical? Because I know you mentioned that a little bit. Do you want to go in a little bit about that?
So that's a really good question. The algorithm itself is not ethical in and of itself. It's the way that it's used and applied that creates an ethical situation. So you can start with data that's biased and feed it into a mathematical model, and the end result will be biased, whether or not the algorithm itself is biased. It's not, it's math. But the way that it's been trained and taught and applied is where the ethical conundrums lie. So, in a sense, algorithms in and of themselves are neutral. It's the way that they're used and applied that brings the ethical question. Does that answer get at what you're trying to ask?
Yeah, I think so. It just seems like that's the algorithm itself isn't biased. It's the way how it's constructed that it is, and it kind of leads me to what my other question was, or what are some challenges that could be found with AI and machine learning, and that I think you're alluding to that might be one of the challenges to it, or do you think that's like the main challenge?
So, so the main challenge, the way I had was going to originally answer that question isn't quite getting at what you're asking. So I'm trying to think of a better way to address it. So getting at ethics and data is really about understanding the inputs and the outputs. So so you have data bias. That's one major area of problems. There's the application of the model to make sure that it's not harming individuals that it could be harming. There is whether a model violates privacy issues. Are you using data that really should be private? Does the individual's data have the right to be forgotten? Those kinds of issues. Can you understand the model? One of the examples, kind of an example of like a black box model, a model that's not interpretable, is there was a model built that would distinguish between huskies and wolves. And it was very accurate at distinguishing between huskies and wolves. But when you try to explain why that model was making that decision, what was discovered was that it wasn't focusing on the husky or the wolf, but was focusing on the snow in the background. And that was what the model was actually making its decision on. mathematically. And so is the model itself doing what you intended it to do? Is a focus of ethics in models, in AI and machine learning. Is it, are people who are using the model able to trust the model? I often encounter individuals who are like, oh, that person doesn't trust data. They don't understand data. Really, it's not that they don't trust or understand how to use data. It's really that they have concerns that are valid and reasonable concerns about how the model comes to its decisions, how the model is used, how the model is developed, what goes into the model. And that transparency is missing. And so they don't trust the model because of that. And that is not just a data ethics issue, but that's also an implementation issue. How do you get people to trust the model? So those are concerns that fall in the field of data ethics that are challenges, especially if you're not thinking about them. Because there is this tendency to view math as value neutral when people are using math and people are not value neutral. Data is not value neutral. These are things that we need to think about and try to mitigate for in creating our algorithms, in creating our machine learning solutions, in working in data science.
You talked a little bit about transparency. I'm just shifting gears and just thinking of a question I was thinking of asking. Do you see a trend occurring where the future of technology will be about transparency in terms of AI and machine learning? Because you mentioned that, when people think of ethics and think of fairness, you talked about transparency. Is that something that people would now be thinking more of ethics?
I think so. I think what people want is the trustworthy algorithm, something they can trust. And with that, you need to understand how it's used. And also, this issue of transparency needs to be part of the conversation, because in order to understand whether or not your models are fair, your models preserve privacy, that your models are explainable, you have to be transparent about them. And in cases when people are transparent about the models, we can learn, where their failings are and how we can improve the AI solution so that it is actually an ethical AI solution.
That makes sense. That makes sense. I see where you're coming from. I'm just thinking of more ideas that just when and this is just maybe my lack of knowledge, my lack of experience with data science and algorithms and machine learning. But when it comes to transparency for data and it comes with the all algorithms, for whatever reason, it's I could see it being manipulative in a way where it could be unethical. And so I like how you mentioned, to kind of tie everything together, what I'm trying to say is, I like how you mentioned that, it is neutral in the way of these are all the calculations that you're making and trying to predict, but it's how you try to put into those predictions or calculations that might affect it that would make it unethical. Is that my understanding correctly of it all, or am I perceiving it?
No, that's pretty accurate. It's how it's not the algorithm itself, it's the data that's used. A lot of times it's the data that's used to go into the algorithm, and the imperfections in that data. We have hundreds of years of structural racism, and women didn't have the right to vote until the last century, and all this data that we have available has biases built into it that maybe not what we want to continue in the future. A lot of times people want to use data science and AI because they want something that is value neutral, but then they feed it data that's not value neutral, and the end result is something that violates our own ethical beliefs and systems. So I'm thinking of so there's the Compass case that was talked about. Then there was a case of a major tech company who built a model to help screen applicants. And they used data that they had from history, and they ended up scrapping the AI solution because the model was knocking women when it was producing its results and predicting success in the company. And the reason for that was because it was picking up on the fact that while chess club was good, women's chess was not as good. Well, so even if you took out gender from the equation, there were gendered terms and gendered words and gendered behavior patterns within the resumes that it was picking up on, and it was downgrading women. And that's, that wasn't the goal of the solution when it was being created. It was trying to eliminate that problem. And yet it exacerbated that problem because the data that was fed was not examined for those biases that exist in advance.
I see.
There's the Gender Shades Project, which was looking at facial recognition software. And if you haven't had a chance to, if you haven't heard about the Gender Shades Project, I recommend everybody take a look at it. It's phenomenal. It was done by a group of women out of MIT. And what they looked at is how accurate were different facial recognition software, AI solutions. How accurate were they on different skin tones and different genders? And what they found was that the darker the skin tone, and especially dark-skinned females, it was not as accurate, not even close to being as accurate as it was on the white male, on light-skinned males. And if you think about that, I mean, one everyday example is like you open your phone with your face a lot of times. And if the facial recognition has a hard time identifying you, then it has a hard time opening your phone. But that's small. Think about the solutions that are applied to policing when facial recognition software enters policing, and then you're trying to identify individuals, but you're making incorrect identifications because the model wasn't trained on enough data to be able to identify darker skinned individuals. That becomes an even deeper societal problem. So these, if you want to take, for other examples of AI gone wrong, there's a site called Awful AI, where you can look at issues of where these well-meaning artificial intelligence solutions were created that did not take a moment to look at why there might be bias, why they might not be ethical. And as a result, the end result was something that did harm rather than did good that was intended. I don't think people go out there to make bad AI. I think it's an accidental thing.
Thanks for sharing that. I'm going to be shifting a little bit because there are actually some cute questions in the Q&A. I know we're going to save them towards the end, but I feel like since we're moving this trajectory, I actually want to bring them in. So, so someone asked, how do you encourage practical dialogue among teams when it comes to ethical AI?
That's a really good question. That is a really good question. It starts with having one person who brings it up. That's the honest truth. That encouraging dialogue is one, educating yourself, and then bringing up those conversations in the meeting. And when you're talking about, what can this algorithm do? So say you have an algorithm that is going to trying to find a good example. Say you have an algorithm that is recommending majors to people at an academic university. It's helping people, is helping relieve some of the workload on a career manager. But because there's bias in the data, because there are current gendered behaviors where there are more women in the health services industry and more men in engineering, it's all of a sudden it's not giving women the options and men the options to pursue those careers. If you're building that algorithm, understanding, hey, what are some biases in these data? Let's start there. Is the data biased, and how is it biased, and will that affect our outcomes? Another conversation to have is like, great, we have this model that's like 90% accurate or 99% accurate. Is it identifying the things that we really want it to be identifying? How do we use tools like Lime and Shapely to identify where these decisions are being made? What's the decision point on these? And is it doing what we're have those conversations? Bring those up. It just takes one person to talk and bring it up. I mean, that's how things started in at Pandata. We started small and we started talking about ethics. And, you know, one person brought it up and then got other people thinking about it. And then once people started thinking about it, they started doing their own research into it and started becoming their own decisions about and thoughts about what it means to be ethical. And then that became part of who we are as a brand and an identity. So I think that is like key, is how to have these discussions, bring them up, start them.
I believe from my understanding, Pandata tries to solidify trust with everyone. Someone had a question of, so how do we improve these biased data sets, and how does the industry build trust when these biases are ambiguous in the data?
Okay, that's a great question. So there is an industry developing to generate unbiased data sets. That's their start. And unfortunately, I don't remember the companies off my head, but I know that, you know, when I attend ethical AI conferences, they're there. There's also tools like the IBM Fairness 360 that helps you look at the data to see if it has biases, and then also ways in which you can modify the data to mitigate some of those biases. So the conversation is happening, and we're starting to develop the tools we need to kind of make the future that we want rather than the future that we had. And so these, yeah, so those are those tools available to you. And there are others out there that don't have at the top of my head, unfortunately, but they are there. So that's one way. Being upfront with what your results are. That's part of building trust. You know, if your tool is only, you know, 75% accurate on one population, 98% accurate on all the other populations, be upfront about that. That builds trust. Then people know, okay, when dealing with the population that it sometimes gets wrong, we need to delve deeper into that. Educating your users, your end users, about the limits to your software, the limits to your AI. That's another big step. People have a tendency to want to provide perfection, and what I've learned is that sometimes honesty is in what you can provide is such a relief to the clients that receive it. They're like, okay, you're being honest with me, you're telling me what my limits are, and that makes me able to make the best decisions with this solution that I have.
Got it. Someone asked another question that they know that Google is currently undergoing these challenges in ethics. What are ways that we can mitigate unintentional bias in our code? And what kinds of methods can we use to analyze these in the models that we create?
That's a great question. So I mentioned AI Fairness 360 from IBM. And I think Microsoft also has some tools available in their Azure workspace to look at group accuracy rates to kind of break down into populations that you're looking at and accurate within those populations as you are accurate for the whole group in a whole, for the populations to see that. That's a tool that's available out there. Lime and Shapely, and there are Python libraries called Lime and Shap. Those are post hoc algorithms. So what you do is, what I've done is you have your black box, you use an intermediate algorithm to understand what your black box has been labeling, and then you put it into a Lime model, and the Lime model tells you the local reasoning. It doesn't give you an explanation for like why every single decision is made, but why that specific decision was made. And you can use that to explore whether or not the decisions that you're making are based on fair reasoning. The Shapley algorithm is another algorithm that does something similar in different ways. There's some really great research articles out there that talk about methods that you can use to improve on the results that you have in terms of ethics as well. Those are some solutions, and to build ethical code. And the start is really that first question: is this code ethical? You may not get it perfectly right the first time, and that is okay, because you're asking the question, you're trying to solve the solution, you're trying to make us be part of the solution. And you know, before I discovered some of these tools, I would do clustering. I would take a black box model and cluster it to see, you know, what are the features that are clustering together. Just trying the solution to try to understand what my algorithm was telling me was the start. And then as this conversation gets deeper and stronger, we'll have more tools available to us, I think.
Well, thank you. So I'm going to completely shift gears here and talk about kind of like tips for success for people in this field. So according to an article by Boston Consulting Group, an American management consulting firm, from March 2020, titled "What's Keeping Women Out of Data Science?" They stated that consensus across various surveys is that only about 15% to 22% of all professionals in the data science related roles are women, indicating that, you know, this field seems to be more male dominated. Do you have any tips for success for women in this field?
Yes. So I'll tell you a little bit about my story and how I chose the company that I chose. Archaeology and anthropology are male-dominated fields, especially archaeology. And so I was coming from a background of already having had experience with a male-dominated profession. And I knew that what I wanted most was a culture that was amenable to women in a workplace. So when I was looking for jobs, I looked to see who was in the leadership. And I saw that at Pandata, there were 2/3 of the leadership was female. There were women in leadership. That was a great sign. I looked to company values, and that was a great sign. And so those are things the two things when you're on the job market: look who your leaders are, look what they're saying, look at what the culture is of the company. And that'll help you find an organization that will help. 2, find a mentor. That helped me a lot. When I started out on this journey, I was scared of code, and I was terrified of what the future was going to hold. And I found a women's coding group, the Pi Ladies, which I am an organizer with. And I met a data scientist there who was a woman who was strong and had skills. And she was willing to welcome me with open arms into the organization. And she helped mentor me. And having a strong woman mentor meant a lot. Having that person be outside of my company, the company I worked with, also helped because it creates a different dynamic. You can talk about things that you can't really talk about internally. Or you could, but it's always a risk. So having a strong mentor was very important and has always been important. Having within the company, having strong relationships with people in positions of authority, finding internal mentors as well. And they don't have to, and sometimes you can find a good male mentor. A man can be a good mentor to a woman. That's possible as well. And you know, having more than one mentor is good, and having them of different genders and, you know, different perspectives is good. So that's two, finding a good mentor. And the third thing is help others. I think that's very important. I think it's important to be, you know, after you've gotten established within your career, once you become a senior data scientist or a senior software developer or even higher positions, that you open your arms to women who are trying to make that jump themselves, and encourage them and help them and mentor them. I think that if there's be the change you want in the world is a very, very good mantra. I think that that helping other women is important.
Thanks for sharing that. I did want to touch upon, I think we mentioned it a little bit, but I don't know if everyone knows, but you have a background in anthropology and archaeology, and you switched over to data science. And my question is, what advice do you have for someone who wants to get into data science field that doesn't have that data background? So I kind of want to touch upon, you have that experience of switching over to data science, and an additional question to that of like, you switched, what advice do you have for someone who also wants to switch? Additional to that is, what made you want to choose data science?
Okay, so I'll start with the second question first. What made me want to choose data science? I have I've done research, and I did research, and yes, in archaeology, my data set was huge. It had 500 data points. I mean, it's small numbers. You know, most archaeologists are dealing with 10. If they have 10 data points, they're dealing with a lot. So it's small data. But it was research, and it was interesting, and I liked doing research. And so when I was looking to transition to careers, I thought about the things that I liked about my current career. What did I like? And I liked helping people as a teacher. I liked, you know, solving problems. I liked putting the puzzle pieces together. And I thought, you know, data science seemed very good fit for that, especially in the more applied aspects of data science, which is what I do. I'm an applied data scientist. I take great ideas other people have and apply them to business solutions. And so that is the answer to the second question. In the first question, what advice do I have for people who are switching over? One, do your research. There's this concept that few people really have internalized that it made the world of difference to me: the informational interview. People think of interviews and they automatically think, oh, I'm going to get a job, right? But there's this informational interview where you're going in to talk to someone just to pick their brain about their job with no expectations whatsoever. You're asking someone to share what their day-to-day life is. And I did hundreds of them. I talked to teachers, I talked to administrators, I talked to data scientists, I talked to whoever I could get a hand on to try to figure out what career would be a good path for me. And having, you know, maybe not do so many, but like, if you're interested in being a data scientist, talk to a data scientist. If you want to know what life is like for a woman data scientist, talk to a woman data scientist. I found that even cold calling people and like sending them LinkedIn messages and being like, hi, you know, this is my background. I just want to talk to you and have an informational interview. Do you have some time? I never got a no. People are willing to talk about themselves. They're willing to share information with you. They're willing to help each other out. And I do it for people all the time. I'm often, you know, touched by, especially boot camp grads, for informational interviews about, you know, how you transition out of that. The informational interview is great. Then networking related to that, making connections. I heard about my job, my current position at Pandata, because I met a woman at a Python conference who happened to know someone at the company who posted, oh, they're looking for people. And I was like, wow, that's a perfect job. I applied. And it wasn't, I wouldn't have heard about that job had I not met that woman, who was a great, personal contact and has been a mentor occasionally to me at times as well. Meeting people, talking to people, sharing your excitement about things. That's how, you break into an industry. And that's very important. I also know not from my personal experience, but from others who are self-taught data scientists, your web presence is important. Make a website, show off your software, show off your algorithms, show off your skills, do 100 days of code, just have a web presence, be out there, be seen. That's important. So those are the 3 tips that I would have for someone who wants to transition.
In terms of building a presence, what kind of technical skills would someone need to kind of promote themselves, that they would know all these things to be a data science? Like, what would you suggest? What would you want to see for someone who wants to get into that field in terms of technical skills or even soft skills?
Oh, wonderful question. I love it. So we'll start with the soft skills. Soft skills are so important. People don't realize how important it is to be able to communicate with clients, to communicate with people. When you're a data scientist, you're talking to people who are in the VP level, CEO, the C-suite. You're trying to help them make decisions based on data that you've analyzed through and algorithms that you've produced. And you need to be able to communicate and communicate well. So communication with an executive means get straight to the point. Don't be super wordy in written form, bullet points. I remember learning to write for business, and like the bullet point was like hammered into me. That is your friend. Learning how to have a conversation with someone that you don't know, which is really hard. Like, even if you start like making small talk, building those skills, making small talk at the grocery store or when you go out, just learning how to talk to people that you've never spoken to before is an important skill to have. And then working with teams, being collaborative and cooperative are important skills to have. And in terms of technical skills, that's a big question, because it depends on what kind of data scientist you want to be. Do you want to be someone who specializes in cloud architecture? And then that's a different set of skills that you need to develop. Do you want to be someone who does research-based machine learning? Then that's a set of skills. Applied machine learning is another set of skills. So really understanding what kind of position you want to, what kind of data scientist you want to be, is important to understanding what kind of skills you want to develop. I focused on developing Python skills and SQL skills. I know a little bit of R, but I'm not very proficient in it. But for me, it was Python and SQL that were the main things that I focused on in developing for myself. I know other people who, not only do they want to know Python, they wanted to know Python, but they also wanted to build their own website from scratch. So they learned HTML, CSS, JavaScript, that suite of materials. They also wanted to learn how to use C to speed up their, Python and to speed up their algorithm design. So it really is what you want to become at the end that tells you how to get that what you want to become as a data scientist helps drive what you want to learn.
That makes sense. That I can't add anything more to that other than that makes complete sense. I have another question. Someone asked if you could go back in time to when you got your first data science job, what would be your number one piece of advice to yourself? I think the first data science job was Pandata, was it?
Yes,
right after boot camp?
Yes, it was. If I could go back in time and tell myself and give myself any advice about getting that first job. You know, I would tell myself to breathe. You'll get it. It's overwhelming. Your first job after, especially after a boot camp, they get you part of the way there. The job takes you the other, 20, 30%, in terms of knowledge base. And I remember being there, being asked to do, I was a boot camp student. We hadn't covered, I got my job 4 months into my boot camp. We hadn't covered NLP processes. And the first project that I was assigned was an NLP project. And I remember my supervisor was going through a list of concepts and to explain what was going on with the algorithm. And I had no clue what she was talking about. And she says, well, write these words down and look them up, because you're going to have to at least have a basic understanding of what they mean to be able to work on this algorithm. So that freaked me out. I felt so dumb, frankly. I felt stupid. I would tell myself, you'll learn it, you'll get there, and you'll grow. And I went from a junior data scientist to a data scientist in a year. Give yourself the permission to breathe. It's okay, you will learn it. You'll get there, is what I would say.
That's that's great advice, and I also commend you for 4 months into the boot camp, and you were able to get that, and I'm sure it was a big learning curve. But I think I really appreciate that Pandata was like, okay, you know what? Here is what you'll learn, and we'll learn together. Or that's what it sounded like. We'll help you along the way, and that's a really good support system to have. So I'm really happy that you had that for Pandata.
Yeah.
One question someone asked, this will maybe possibly be the last question, but how did you juggle the boot camp and finding a job? And what are some questions do you suggest asking mentors?
That's a great question. Juggling the boot camp and finding the job was tough. Really what it came down to was finding time to go to meetups, professional meetups like this one, and talking to people. That was the start, going to conferences, local regional conferences in the field that you're focusing on or in the language that you're focusing on. That was a big help. So my advice anytime anyone's talking about doing multiple things at the same time, like a class and work, your calendar is, you live and die by that calendar. Like, keep that schedule, make time for the people that you need to make time for, and make time for yourself, and make time to do these things. And it's tough, but live and die by that calendar. And the second question was, could you repeat the second part of the question?
Yes, the second question what are some questions do you suggest asking mentors?
Okay, that's a really good question as well. How did you get started in this field? What would you tell yourself if you were doing it over again? What do you like about your job? What is an average day? How would you suggest someone break into this field? One conversation to have is, after you've secured that the person is your mentor, have a discussion about what the expectations are. How often will you meet? What kind of mentorship are you looking for? That kind of thing. Those are the kinds of questions I would ask.
Awesome. And then, gosh, we're running out of time, but one last question that I always ask all of our people that we do our shout out Saturdays. So if any last words of wisdom for those in data science positions. You had a lot of pearls of wisdom that are so great, but if there's one last one we could end with, what would it be?
This is something that I learned early on in my professional life, and it applies to a lot. The pearl of wisdom is, because we're human and we fail, right? And we're not perfect. There is no such thing as good and evil. There's just people trying to be decent and try to be that. And I think that that is by far the biggest pearl of wisdom I've ever had, is just try to be decent.
Thanks for sharing that, Julie. I really wish we could have more time to talk, but thank you again for taking the time to meet with all of us. And I enjoyed our chat today, and I appreciate again for you sharing your experience and perspective. I think some people are wondering if they could reach you out in LinkedIn or contact you. Would that be
Yes,
okay?
definitely. Please feel free.
Cool. I think what we'll do is we could maybe if ever I think everyone on here is logged on to the meetup, we could leave a comment of your LinkedIn URL
Mhm.
there. I don't know if I can link your LinkedIn at this moment, but we can do that for the meetup, everyone. If that's all right with everyone. Um, all right. So thank you again, everyone who attended our event for Shout Out Saturdays. The summary of this interview is planned to be posted on our chapter blog. Follow us on our Medium blog to get update on our recent updates and join our community at Linktree / WWCode SV, where you can access previous recordings of our events, view our Women Who Code chapter future events, and follow us on our social media platforms. Just a reminder, the concept of Shout Out Saturday series was promoting women professionals who want to share their insight into the tech world through overcoming obstacles, highlighting accomplishments or their passions, or tech industry advice. So if you enjoyed this session, would like to share your career journey, or know someone who would be a good fit, please reach out to us and let us know, and send us an email to sv@womanwhocode.com with the subject line Shout Out Saturday application. Thanks again, everyone. Have a great weekend. And again, we will definitely give Julie's LinkedIn URL over in the meetup comment area, and also in our Slack as well for our members. And that's it for today. Thank you again, Julie. This is such great information. Thank you for sharing your insight, all about ethics for machine learning, AI, and all your real tons of advice for your career and just your experience. It was really helpful. Thank you.
I'm glad I could share. Thank you for having me.
Mhm. Bye, everyone.
Bye.